In this example, we're going to look at how ammonium ions behave when they're in water or in strong base. Ammonium ions, remember, are a nitrogen that have 4 bonds to it. In this case, we have trimethylammonium. So I'm going to draw the methyl groups as lines because the end represents a CH3. And then the 4th bond is going to be an H. And because there are 4 bonds around nitrogen, this ammonium has a positive charge. So this is trimethylammonium. Methyl, 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 and then the H. So it's trimethylammonium. And we are reacting this with water. And because trimethylammonium is going to act as a weak acid, we're going to have an equilibrium, which means we're going to have reactants and products at equilibrium. As I mentioned, the ammonium acts as an acid. This is in contrast to the amine, which only acts as a base. So the ammonium acts as an acid. It's going to donate H+, and the only other thing in solution is the water. So it's going to donate the H+ to the water, which will act as the base. And our products will look like this. We'll have the nitrogen with 3 bonds, and now there's a lone pair where the H was, and we will have the hydronium ion. And so this is called trimethylamine. And this is our product, and then we have the hydronium ion. What you'll notice is that there was the ammonium, which has a positive charge as a reactant, and in the product we have hydronium, which has a positive charge. So between the between the reactants and the products, each side has a +1 charge, which means that our charge is balanced. So our trimethylammonium acts as an acid. It donates H+ to water, and we get trimethylamine and hydronium ions. And this is an equilibrium because the trimethylammonium is a weak acid. Now I'm going to do the reaction between methylammonium and sodium hydroxide. So methylammonium I'm going to draw in a condensed structural formula. And so what we see here is that I have the nitrogen bonded to 3 hydrogens and a single methyl. And because it has a total of 4 bonds, it has a positive charge. I'm going to add this to NaOH. Now if I were to draw this methylammonium ion in a line bond structure, I would draw it like this. So there is our methyl group bonded to the nitrogen. And then I can draw it as this, or I could draw it with the methyl group bonded to the nitrogen, and I could show each of the H's. And what we see is that this and this and this all represent the same thing, and the upshot is that there are 4 bonds to nitrogen, so it has a positive charge. Now we're reacting a weak acid with the strong base, sodium hydroxide, so it's going to be a single arrow. And just as was the case with ammonium, with trimethylammonium reacting with water, the ammonium ion acts as an acid. It's going to donate an H+ to whatever base there is. And the base that we have is the OH-. So we're going to make water, and we're going to have methylamine. And there will also be some Na+ or sodium plus ions in the solution, so that our charge stays balanced between the reactant side, which has a plus charge, and the product side, which has a plus charge. And this product right here is called methylamine. And now, as you see, the nitrogen has 2 hydrogens bonded to it and a methyl group. So therefore, with 3 hydrogens bonded, it's also going to have, with 3 things bonded, 2 hydrogens, 1 methyl group, it will also have a lone pair. And here we've seen methyl ammonium ions act as an acid, donate an H plus to the OH to form water and methylamine along with some sodium ions.